Hello guys, this is Group 5 of Division N of VIT Pune. Our group member consists of Anshu Parihar, Aryan Pari, Sakshi Parki, Bhargav Parlikal, Diksha Parshram and Parth Jadhav. We are guided by Professor Lokesh Khedkar sir for subject Computer Organization and Architecture. Our topic for presentation is memory hierarchy. Now, let us see what is memory hierarchy. First, what is memory? Memory is a device or system that is used to store information for immediate use in computer or other related computer hardware and digital electronic devices. There are two types of memory. First is internal memory, which is directly accessed by processor. Second is external memory, which is not directly accessed by the processor. Now, what is meant by memory hierarchy? Memory hierarchy is the hierarchical arrangement of storage in current computer architecture. It is designed to take advantage of memory locality in computer programs. Each level of the hierarchy has the property of higher bandwidth, smaller size, and lower latency than lower level. For example, L1 cache is closer to the CPU, so it can be accessed quickly and it is more expensive and contain less data. Similarly, a mass storage device like a hard drive is accessed slowly, it is least expensive and hold large amount of data. Here is an example of the memory hierarchy. Here, L0 represent the CPU register, L1 and L2 represent the static random access memory, L3 represent the main memory, that is dynamic random access memory, and L4 and L5 represent local secondary storage and remote secondary storage, that is local disk, web server, distribute file system. Also, L0, L1, L2, L3 represent the internal memory, which are the temporary storage area, and L5 and L4 represent permanent storage area. As we move from bottom to top in a hierarchy, speed and cost per bit increases. Also, as we move from top to bottom in the hierarchy, access time and capacity increases.
Hi guys, this is Aryan from Group 5 and I will be explaining the different characteristics of memory. So in memory, the first characteristic that we look at is location. In location, we have internal and external memory. So internal memory is memory that is based directly on the computer and that can be directly accessed by the CPU. So this includes cache and registers. Cache and registers are both directly mounted on the computer and can be directly accessed from by the CPU itself. Next, we have external memory. External memory can be the memory of peripherals such as speakers or SSDs or any other type of memory that is not directly mounted onto the computer. Second characteristic that we will be looking at is the capacity. So capacity is the amount of storage that can be stored on these devices. Devices like cache can store a very short amount of data because they are very high speed devices. But SSDs and main memory can store a lot more data. Lastly, we have the units of transfer. So units of transfer are the number of electrical lines into and out of the memory module. So in internal memory, this can also be called as the word length. But for external memory, as we are dealing with much larger amounts of data, we use blocks.
Hello guys, I'm Bhargav from Group 5 and I am here to explain methods of accessing units of data. First, what is access method? An access method defines the technique that is used to store and retrieve data. So what are the different methods of accessing units of data? So first is sequential access. In sequential access, this method reads data in a linear fashion, such as reading a file from beginning to end. It means that you have to go through each element one by one. It can be used in cases where the data is not too large or the specific element is not needed accessed frequently. In this type, memory is organized into units of data and is called as records. The access time depends on the location of the data. So, the applications of the sequential memory access are magnetic tapes and disks. So, the next method is direct access. Direct access is the process of reading and writing data on a storage device by going directly to where the data is physically located on the device rather than having to move sequentially from one physical location to the next to find the correct data. The term direct access is often considered synonymous with random access because data is accessed randomly rather than sequentially. Direct access relies on addressing techniques that enables the operating system to identify the data's location without having to search for the data. In this way, the operating system can go to a specific physical location on the storage device wherever the data is stored, making it possible for applications to read or write data much faster than they could if accessing the data sequentially. The application of direct memory access is magnetic hard disk. The next type is random access. In this method, any location of the memory can be accessed randomly like accessing an array. Physical locations are independent in this access method. In this type, any location can be selected at random and directly addressed and accessed. So, the time to access a given location is independent of the sequence of prior accesses and is constant. Applications of this random memory access are RAM and ROM. The last type is associative access. In this memory, a word is accessed rather than its address. This access method is a special type of random access method. A word is retrieved based on a portion of its content rather than its address. Each location has its own addressing mechanism and retrieval time is constant independent of location or prior access patterns. Thus, the application of associative memory access is cache memory. Now, let's move to performance. The two most important characteristics of memory are capacity and performance. So, performance is checked by three parameters, and they are access time or latency, second, memory cycle time, and third, transfer rate. Access time is nothing but the time required to access the memory, and transfer rate is the rate at which the data is being transferred. So, this is all about performance.
Main memory organization, the memory unit that communicates directly with the CPU, actual memory and cache memory is called main memory. It is the central storage unit of computer system. It is a large and fast memory used to store data during computer operations. Main memory is made up of RAM and ROM, with RAM integrates circuit chips holding the major share. RAM stands for Random Access Memory. RAM is a type of memory that can be read, formed, or written. Therefore, a read or written random access memory. This memory stores the input data and the program that user gives to the computer for immediate execution. RAM is a volatile, meaning that it stores its content when the power is shut off. Random access means the storage cells of a RAM memory are organized so that access time of any cell is the same for all. Now, types of RAM. There are two types of RAM, dynamic RAM and static RAM. Most commonly used type of system memory is dynamic RAM. It requires refreshing in every few milliseconds. It holds the data for very short time. It is less expensive than static RAM. Moving on to static RAM. Static RAM holds the data until power is turned off without need of refreshing, though it is more expensive than DRAM or dynamic RAM.
Hello guys, now I will be explaining you ROM, that is read only memory. ROM is a type of memory that can be read from but cannot be written to. ROM is a non-volatile, meaning that it retains its contents even when the power is shut off. These programs are written permanently into the memory during manufacture. Such programs are called the firmware, which means a specific class of computer software that provides the low level control for a device specific hardware. Next is the type of ROMs. First is the PROM. PROM stands for Programmable Read Only Memory. It is a computer memory chip and it is possible to program it once after creation. After programming the PROM, the information we write to it becomes permanent. Therefore, we cannot erase or delete that written data.
Hello, this is Diksha Parsharam from Group 5. So the second type of ROM is EEPROM. EEPROM stands for Erasable Programmable Read-Only Memory. We can erase and reprogram an EEPROM without replacing it. It is possible to erase and write to it by exposing the memory chip to ultraviolet light. The third type is EEPROM. EEPROM stands for Electrically Erasable Programmable Read-Only Memory. It is a memory chip that we can erase and reprogram using electrical charge. It consists of a collection of floating gate transistors. The flash memory is a type of EEPROM which has a higher density and lower number of write cycles. So this was all about memory in short. Thank you.